Ooh, where's my music? Come back. What's up, Amog?
That's dope.
Let me stop the music. That music, dude. I love it, dude. Come on, say hi. Goldie Woldy, he says. Goldie Woldy. Are you still on the bus back to school, Amog, right now? You on the bus? Probably is. I made a delicious sandwich today for lunch. Middle aisle again. Oh no. You don't have enough seats on your bus, dog? Excuse me? How do they not have enough seats on your bus? Floor's vibe in school is broke. Uh-oh. That's unfortunate. All the money goes to the American football team. Yeah. American football's pretty dope. You know, it gets a lot of money. Ooh, we got lots of good questions today. Ooh, Teacup has one first, too. And Kaz has one. Wow, we got all sorts of questions today. And then could I ping Jamarcus? Yeah, sure. Got you guys. All right, cool. We pull Bob's in. Unless Teacup shows up right away. Then I'll do his. But Bob's here. Bob East here. Okay. Cool. All right, cool. Let's start off stream. All right. Welcome everyone to Office Hours. My name is Dr. Gold, Actual Education. The stream that helps you out with math homework, science homework, all types of fun stuff. Hope you guys had an awesome Thanksgiving break. I ate a lot of food. It was awesome. I taught a lot too. There's a lot of students that had exams and stuff, so I had a lot of teaching over the break. And I have more teaching this week because all your teachers are probably realizing, oh shit, we need to give out a midterm, you know, because at the end of the year is coming up and we got to get you ready for finals. What's up, Noise? Good to see you too. All right, Bob, let's see what we got here. This looks like a differential question or something, right? Let me turn my fan on. It's hot. Okay, there we go. Getting close to finals, Bob, right? Isn't that like next week for you guys? For USC?
Yeah.
Oh, fuck.
For this class is next Wednesday.
Oh, no. The second they give you a practice final, like, let me know. Let me help you.
Okay.
Okay. Pressure and volume inside a spherical soap bubble satisfies the equation PV is equal to K, where K is a constant. Initially, the radius of the bubble is 6. If the pressure increases by 0.5%, if delta P equals 0.05 P, estimate the change in the radius of the bubble. We remind you that well, I'm glad they remind you about this. Yeah, that's great. Okay. This is like using differentials instead of what do they call it? Instead of full derivatives. Okay.
Mhm.
Which is basically the same thing. So when you're doing this, this is you see how this is a product rule, right? PV.
Yeah.
Okay. So that's going to be delta P times V plus P delta V is equal to delta K. Okay?
Yeah.
Okay, great. They
Mhm.
said K was a constant, though, right? So that kind of helps me out, right?
And
Del-
K is 0.
K, delta K is 0, yeah, because it's a constant. No change in K. Okay, awesome. And so they tell us that delta P is 0.05 P. That's pretty cool. So I know what this is, right? So I say that 0.005 P V plus P delta V is equal to 0. Okay. And then this is what they say for R, for V, right? We say that V is equal to 4/3 pi R cubed. Okay, so then what would delta V be equal to?
Is that the derivative of V?
Yes, it's the implicit derivative of V, yeah.
It'd be 12 over 4,
Go up 12 over.
4 pi R dr.
So close.
Or
You,
delta R.
you take this down, right? So that's 12 over 3, which is just 4, right?
Yeah.
Pi R squared. And then instead
yeah, R
of dr,
squared.
we're going to put delta R. Okay? All right.
Uh-huh.
Okay, so now you can replace this with this, right? So now I have 0.005 PV plus P, and then this is going to be 4 pi R squared delta R.
Can you change the V? Can you change the V to 4 over 3 pi R whatever?
Exactly. You can too as well. Yep. There. Go away. Come on. There. Yes, you're right. So we can do this. We can say 4/3 pi R cubed, right?
Mm-hmm.
Okay. Some things I see we can take away, right? You see how we have a P in each statement here?
Yeah, divide by P.
Divide by P. That goes away. Goodbye. Okay, cool. We can also get rid of the 4, right? There's a 4 on both of these. We can get rid of the pi. There's a pi on both of these. Oh, we're just like getting rid of everything, aren't we, today? Okay.
Get rid of some R's also.
Yeah, let's get rid of some R's. Yeah, good. I like that. Yeah, let's get rid of all these R's, and then this one just has one of them left, right? So now we're left with 0.005 over 3 times R is equal to negative delta R, I guess. Yeah, negative delta R, right?
Yeah.
Okay. So it's pretty easy. And they tell us the radius of the bubble is 6 centimeters, right? Okay, cool. So
Oh, do you just plug that in?
yeah, you just plug it in, I think, right? I don't think there's anything tricky about this, right? So this is point. Question is, do they want it in? Oh. Yeah, well, here's the question. Do they want the change in the radius? Do they want this in terms of a percentage? Do you think they want it in terms of a percentage? What's up, Penn Center?
Estimate the change in radius of the bubble.
Yeah. Because you see how they said that, like, P increases by 0.5%, and they say we represent that as this, right? Delta P is 0.005, right? See how this is, like, 0.5% P?
Yeah.
Because really what they're saying is, like, delta P over P is equal to 0.005. This is really how we represent. This is called, like, a relative change. We say that the pressure is changing at, it's 0.5%, yeah. So really, I think what you want to say here is, initially the radius is this. Yeah, I think they want to say this. I think we just want to say that delta R over R is equal to negative 0.005 over 3. So that means that's equal to, what is that? Negative 0.167%. I think that's what they want.
Is that 0.03 over 3? Wait.
So this right here, right? This becomes negative 0.00167. Okay. I'm pretty sure.
Oh.
Right.
Wait, how'd you get that?
Because I did 0.005 divided by 3, right?
Uh-huh.
And then that as a percentage is negative 0.167%.
Okay. Oh, okay, I see now.
Yeah. Okay. Yeah, I think that's what they want. Do you have the answer for this one?
No.
No?
He hasn't even gone over this yet, but like I just found it off like past finals.
Okay. Yeah, I think
I don't
this
know
is
if he
correct.
will.
I mean, technically you could also put in... You could put in what the radius is, I guess. But... Technically that's changing, right?
Uh-huh.
So... I think this is correct. I think this is what you want.
Alright. Thank you.
You're welcome, dude. Nice. Got some calculus under the belt today. Love it. We have another Bob in here, dude. What? Oh, there's a guy named Mad who's also Bob, apparently. But there's only one Bob the Goat. Okay, let's see. What are the questions we got? Moog, dude. I love your question, dude, bro. What? Teacup's got a good question. That's a differential... Teacup just keeps asking, like, really, really ridiculous stuff. But okay. Let's see. Yeah, I kind of like this one, Amog. Yeah, that's a good one. Is this legitimately your question? You have to be here to kind of answer it though, Amog. You can't just like drop a question and then not do anything with it. Also, like, dude, I know you're going over harder shit than this, dude. Yeah, what? Like, come on. I know you are. You're a goofy goober. Yeah, false. Aren't you in physics this year? You're in AP Physics, I thought. Yeah, physics and chem. Okay, that's cool. I almost want to like ask you a chem question. Cause bro, you know, yeah, this is an actual, I guess, picture of him on the school bus. Wait, you're not sitting in the aisle, dude. You're sitting on a seat. Thought you said you were being poor, sitting in the center. Oh, first stop gone. Okay, seats open up. Okay, we do like that. I want to think of a. I mean, I do appreciate your craftsmanship here. This is kind of nice, I guess. I appreciate that, like, you took the time to, like, draw all of this out. That's, like, a lot to draw. Oops, and now it's gone. Okay. Sure. Do you know how you do this one, Amog? I'm going to ask you another question after this anyways, but, yeah, I want you to also do this one. You get to do 2 with us. Ba, 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 ba. Oh, use the exponents. Okay. Y-intercept is 2. Yeah, very good. Yeah, so you know this. This is just. Yeah, I don't think there is a subscript on the phone. Yeah, this is just y minus y1 equals m x1 or x minus x1, right? Or oh, you can do y equals mx plus b. Yeah, you could do that too. Yeah, you're right. So yeah, this would just be 3 minus 1 for the slope, and then this is 1 minus 2. So that's 2 over 3. Cool. Good. You got the slope. And then you go y is equal to 2/3 x plus 2. Yeah, that's like super simple. Super simple. We're doing isotopes and stuff. Okay. Isotopes are great. Yeah, I do like isotopes. Oh, that's so nice of you, Tortoise, dude. But like, no. Sorta. Yeah, you could. Have you done like atomic mass for like different compounds? That's a good one. Why do they do relative atomic mass? I don't like that. What the fuck is relative atomic mass, dude? What? I don't like just a simple like isotope question. Oh, they call it relative abundance? Ew. I'm entering a dead zone, sort of. What do you mean a dead zone? What? Where are you in the United States that you don't have cell phone reception? What? Oh, okay. Yeah, cool. Washington. Oh, yeah, I guess Washington probably has some area. We only have trees! Better than some places where you don't have anything, man. One sec. Chemistry isotopes. Yes, here we go. This is a good one. I like this. Do a little bit of chemistry today. All right. Fictitious element Z has 3 naturally occurring isotopes in nature. Does anyone know what an isotope is? What does it mean for something to be an isotope? Maybe you've seen something like... Oh, this is too big. Like, for instance, like carbon-14. You've seen this like carbon-14 dating or something? It's not when carbon-14 goes on a date. That's not carbon dating. They use it in order to figure out how old things are. It's pretty cool. Let me see. Carbon mass. Yes. Okay. Carbon normally, right, has 6 protons. Okay. That's what makes it carbon. This is also called like the atomic number. Okay. The number of protons that something has kind of defines what it is. So if something has 6 protons, it's got to be carbon. That's the element. All right. And then we can also talk about the amount of electrons. Okay. So if something is neutral, okay, the amount of protons has to equal the number of electrons. So here we'd probably say this is 6 electrons. All right. And then it can have a certain number of neutrons. Okay. Let's say, for example, that this thing has 6 neutrons. All right. If we want to define the mass, we say carbon mass, right? This would be equal to 12 AMU. AMU stands for like atomic mass unit. And so how we got that 12 is we added the number of protons to the number of neutrons. The reason why we don't add the electrons is that the electrons are really, really like tiny. They're very light. They don't really contribute to mass at all. They do a little bit, but not really. So, yeah, this is what regular carbon 12 is. And the way they would write that is they would write C612. Okay? Now, what can happen is carbon can start to acquire more neutrons. It can get like a little bit heavier. Let's say carbon goes to, I don't know, a Thanksgiving dinner or something and eats like way too much stuffing, which is my favorite. Or, you know, apple pie with ice cream or something. Carbon can gain more mass. So when that happens, we have things which are called isotopes. So isotopes are elements with a different number of neutrons. Okay? So, in some case, let's say, for instance, we have carbon 14. Okay? This means this is a carbon with a mass of 14. Okay? Now, carbon, if it's carbon, will always have 6 protons. Don't worry about the electrons. The electrons don't really contribute to any of the mass. So if we wanted to figure out the number of neutrons this has, this would then have to have, here, I'll bring you back up. This would have to have 8 neutrons, because that's how we get a mass of equal to 14. Okay? And this they would call carbon 14. Carbon 14 is actually unstable, is what it is. So, you know, because it has those extra amount of neutrons, it doesn't like to stay as carbon 14, so it's actually kind of radioactive, is what it is. And as when something dies, it has a certain amount of carbon 14 in it. And as the thing decays, the amount of carbon 14 converts into carbon 12, like the regular carbon. And what we can do with carbon dating is you can see the percentage. What's up, Moog? You can see the amount of what is this? What are you sending me screenshots of, dude? What? Oh, okay. Yes. Okay. Oh, I don't know when this picture will load, but I think it's how you do it. Y equals all the things add together. Yeah. We'll get to it. Kind of. It's close. Yeah. So what they do is they can see how much of the carbon 14 has deteriorated into carbon 12, and then that tells you how old something is, because it can tell you how long it's been deteriorating for. Yeah. But yes, you are right. So that, again, that's where isotopes come from. You can also get what are called like ions. Okay. Ions are elements with, we say like a different number of electrons. Okay. So for instance, I can have something, let's say carbon 2 minus, which doesn't really happen, but whatever. That would have 6 protons. And now we have to look at the charge on carbon. So if carbon has a 2 minus charge, it means it has an extra 2 negative things on it. And what we learn in chemistry is that electrons are what carry the negative charges. So this would end up having 8 electrons. And that's what it gives it like a minus 2 charge. Yeah. So yeah, that's the difference between isotopes and ions. Carbon 7, like, bro, carbon can't hold more than 7. Carbon 7 minus. Well, I mean, it can. So okay, yeah, carbon 7 minus. Yeah, if you just like jacked this thing full of like carbon of electrons. Yeah, this would have how many would that have? Sorry, that would have 13 electrons, right? And it can, like, technically carbon can hold as many electrons as it needs to. Yeah. I'll show you why. So you could have carbon just chilling here in the center. Okay. What's up? What's up, Justin?
What's good? Yo, y'all, you doing elements?
We're doing chemistry, dog. Elements. Have you done this before?
Oh, you're making like the circles and they have the fucking, what is it? The
orbitals and the shells. Yeah. This is like n equals 1.
Like that, like I'm talking about like the valence, like the fucking numbers on the top right corner.
The valence electrons. Yes,
shit,
exactly.
Bro. Yeah, the valence.
Electrons. Valence.
My teacher says valence. I'll say valence.
Your teacher says valence, dude?
Fuck yeah.
I forgot you're from Florida. Oh man.
I shall not exist in Florida.
I know. 1, 2, 3, 4, 5, 6, 7, whatever. Like this. Okay. So
carbon's element was 6 with a mass of 12 point something, so around 6 neutrons, monkey.
Well,
thank you.
No. It's exactly 6 neutrons. The 0.00 that has to do with the abundance thing.
So let me just send the fucking periodic table of elements into the chat.
Yeah, do it. Yeah.
Well,
yeah.
Give me a second.
Yeah, the reason why it's a decimal, Amog, is it's not because there's partial neutrons, it's because of this whole isotope abundance thing that I'm going to talk about.
Which year do you want? Because there's so many fucking years.
How many years? What do you mean years?
Because there's one from like 1980 that my teacher has.
That's pretty old, dude. It's older than me,
Yeah.
dude.
No.
You found something older than me, dude?
You
That's
want
rare.
the ones that have helium, hydrogen, lithium,
Yeah, let's get the latest one.
Belgium,
Dude. What's up, Patty?
bromium, bromium.
You can come say hi, Patty, if you want.
Here, I'm gonna send this one.
Yo,
Okay,
what's
nice.
good?
Yeah, what's up, Patty? How's your calculus class going?
It's alright. I mean,
Alright.
we're doing derivatives right now.
Oh, derivatives are sick. Okay. Sick.
Yeah, derivatives are cool, I guess.
And then, are you in physics as well?
Nope.
Oh, that's just Philip.
I'm
Philip's in
biology,
physics.
remember?
But Phillips is in physics, though, right?
Yeah, he's in physics.
Wow.
What is this? Chemistry?
Yeah, we're doing a little bit of chem. Have you done chem before?
Yeah, sophomore year.
Sophomore, yeah. So wait. You're taking biology now? I took biology like my freshman year, I feel like.
Well, AP biology.
Oh, I see. AP Bio. Yeah. I fucked up on that AP exam. I got like a 3 on it. I was so mad because it
AP
didn't give
biology?
me. Yeah, I didn't get any credit in college.
That's
I
crazy.
didn't get you any credit,
I
yeah.
get ones in my class.
I'm
bro. like,
aiming for a 4.
4 is good.
Hopefully.
4 gets accepted in some. Yeah, I was mad because I had to take bio like again in college over the summer, and I was like, ugh.
Uh-huh.
Well,
fucking-
they sent the fucking periodic.
Did you send the periodic table? Thank you there, dude. Yeah.
Yeah. Use it.
Patty, do you have any questions on like homework shit you need help with? Like, I got you, dude. If you need,
I
you got a
have-
question.
I have like my thing pulled up right now, like my
Okay.
homework assignment.
Yeah, pull it up.
Uh,
Show me something that's like difficult. You're like, I don't know that.
okay, so we went over this example in class. I have like all the work done for it, but I'm gonna be completely honest, I just copied that shit down.
Well, here, let me just actually
So-
teach it to you. Yeah, you're good.
Alright, yeah. Alright, I'll screenshot.
Yeah.
I think it'll be better if I take a picture on my phone.
Yeah,
So
just-
I was
yeah,
about
you
to screenshot it, email it to myself, and then yeah, that would be a whole process.
No, yeah,
Nope.
you.
How do you like that periodic table?
Picture on my
I like
phone.
it. I like it, dude. Thank you, dude. I appreciate this. I like
I'll
this.
even
periodic
crop
table.
it for you.
Wow, dude. Getting the golden glove treatment here, dude.
For sure.
Yes, you see the yellow?
This is cool, actually. Does this actually what are these? What is this 2.8? What is this shit right here, dude? What the fuck is this stuff?
Oh,
They-
fucking no. It's something. I think this is like an updated version of the periodic table.
I'm trying to are these like the line? Oh, I think this is. Oh,
So last
the
month,
no,
the
this
valence or
no, it's the
valence.
valence electrons. Oh, this is cool, man. Yeah, I like
Oh
this.
my god, valence electrons.
Yeah,
dude.
Yeah, no, but they put the
bad.
numbers on them. Look at this. They say 288 because some of these are weird. Some of these have exceptions in them. Is what they're talking about. Like this one. This one does, for instance. Like nickel.
Nah.
Nickel will like keep 2 in the
Wait.
s orbital, but then like it'll pull these from the last one, and then once you get to these 2, it starts filling these again. It's very interesting how some of these are weird.
Penn Center says, don't you mean the valence?
Valence?
The valence.
No, dude, it's valence. Valence.
I'm telling you it's valence. It's gotta be valence.
Dude, I've never heard valence in my life. Dog.
Got it.
What?
Got it. Alright, tell me the element
It's
of
valence.
It's valence.
valence.
It's valence. It's valence.
It's not valence.
Valence,
Let
dude.
me speak.
Is
Tell me
Valence
the-
like a
tell me the
game?
element-
It's a Valorant.
Valorant.
Tell
Alright.
me the element that's in group 18, period 3.
Yeah, I don't know. I will.
It's
Here.
on the fucking show.
All right, I'll do it for you real quick. What do you want? You want to know what element is what?
Period 18, no, not period 18, group 18, period 3. Tell me.
Argon.
'Cause I'm already looking.
Argon,
No,
right?
Period 3 is.
Oh, Oh,
yeah.
period. Yeah. Period 3. Yeah, there you go. Wow, look. Valence. Wait. Penn Center. Well, he's from Canada. Maybe it's like some Canada shit. Okay, whatever. All right, let me do this question for Patty. Give me a second. Okay, a ball is thrown downwards from a building such that its downwards velocity at 1 second is 76 feet per second, and it is 10 feet above the ground at 2 seconds. Wow. So they give you a lot of information here, dude. Right?
Yeah. And
Yeah.
it's thrown, it's not dropped. So
Yeah. So that means it has like some initial velocity. Okay.
yeah.
So yeah. So they're right to write. They are correct. Sorry, to write these things. Right. It's always good to.
Mhm.
This is actually kind of a physics question, really. It's like math and physics. Is what
Yeah.
It is. Yeah.
Yeah.
Okay.
Type.
So v of 1, right, is equal to negative. They should be saying negative 76. right? That's what
Yep.
I would be saying, negative 6, because it's going
I'm gonna
down.
erase all of this and then rewrite it just so I like get repetition.
Good.
I
Yeah, I like
guess.
that too. Yeah. So I would say v of 1 is negative 76, and yeah, sure, feet per second. Okay.
Yeah, 76 feet per sec.
And then they say it is 10 feet above the ground at 2 seconds. So that means, yeah, s of 2 is
S
equal
of 2 is 10.
to. Kind of cool. And then what you always know, right, is that anything that's accelerating, right, or anything that's in the air, just free fall, right,
Uh-huh.
a is always equal to negative 32, and then that's technically feet per second squared.
Yeah, because
And that's at all team. That's at all time. Mhm.
Yeah.
Well, it's just at all times the acceleration is always minus 32. That's what it always is.
Okay.
Yeah. Notice how, like, technically this is, like, a of t, but there's no t here because acceleration is constant. Yeah. Okay. So the relationships you learn in physics, which maybe you learn these in math, but is, for instance, that, right, ds dt is equal to v, and then dv dt is equal to a. Okay?
ds dt is equal to... okay,
Yeah, so the change in
derivative of the
position.
position is velocity,
Very good.
and then derivative of velocity is acceleration.
Good, exactly. Yeah. Okay.
Yeah, okay.
So from this, right,
Mhm.
I'm going to show you where the equation comes from that they're getting. They're putting this on this side. So they're saying that dv is equal to a dt. Okay?
Okay.
And then they're integrating it is what they're doing. They're integrating both sides. Do you see how, like, I have a dv here and a dt here?
Mm-hmm.
And this is going to go from, like, some v initial, right, to some v final.
Yeah.
And this is going to go from some t initial to some t final. Okay?
Okay.
And so what you end up getting, right, is you get VF minus VI is equal to, what is this? This is A TF minus TI. So really the final velocity is equal to the acceleration times the time. You always kind of assume that the initial time, right, would be 0,
Yeah.
right? So I'd say, okay, so this is just AT, and then this is plus VI. So that's where the equation comes from.
Okay, so... Okay, integrate.
That's the way to do it
Run it.
with definite integrals. Patty, just means that, like, I put, like, things in the bounds. Okay.
Yeah.
Okay. There's a way to do this without putting it in the bounds. Okay. That's what an indefinite integral is, which is maybe what your teacher wants you to do. They want you to do this. Okay. Where
Yeah.
this is just going to get you v is equal to at plus c. Okay.
Mm-hmm.
Where c is a constant. Good. Okay. You can kind of see how, like, okay, look what happens, right? If t is equal to 0, do you see how this all goes away?
Yeah.
And then what would
so
c?
velocity is the constant.
Good. Or the constant is the velocity when t is equal to 0. And the velocity when t is equal to 0 is the initial velocity. So you see how that becomes the same thing?
Mm-hmm.
That's where it comes from. Okay. But we can run with this shit. Okay. Okay. So yeah, because they don't tell you what the initial velocity is. They're asking you to solve for it, right? So what we can do here once we go to here is you can use, this is called, like, using one of the initial conditions. This is an initial condition in order to solve for c. Okay? So I know v of 1, okay, is equal to negative 76.
Yep.
So I'm going to say negative 76 is equal to a, which is negative 32, times what? What would I put in for t here?
Equals negative 32. And then what's the constant?
Well, no, what's t? What do I put in for t here?
Oh, t.
So when I put in
at
this,
2 seconds?
it's not
1 second.
It's at 1 second, right? Because you see how this negative 76 corresponded to when the velocity was being measured at 1 second.
Yeah. Mm-hmm.
That's why it's 1. Okay.
Yeah, 1 second
Good. And then this is
And
plus c.
plus c.
Mm-hmm. So then, you know,
And then,
move this shit over.
Yeah, solve for c.
Good. So what's that? That's
So
negative
C-
44 equal to c.
Sounds about right.
Yeah, all right. Okay. So cool. So now my equation is v is equal to negative 32t minus 44. All right.
Mm-hmm.
And so the initial velocity is when the time is equal to 0, right? That's the velocity when time is equal to 0.
Yeah.
So this goes away, right? So if I say, because I want to figure out v of 0, right? That's equal to negative 32 times 0 minus 44. So that's equal to negative 44 feet per second. And that this right here, this is the initial velocity.
So this is velocity initial.
Good. Yeah. Again, when you end up taking physics, Patty, you're going to learn this equation is what you're going to learn.
Yeah.
Which you can see looks exactly like doing the calculus integral form of it.
The calculus way.
Yes. The only difference is that C is the same thing as V initial.
Okay. So for the sake of calculus, should
For
I
the sake of
just
calculus,
stick to the
you should
left?
do. Yeah, you should do this. Yeah, for the sake of calculus. Yeah.
Okay. 'Cause
I just
wrote
wanted-
down the
Yeah.
Yeah. I understand what you tried to show me.
Yeah.
Okay. So
It depends what your
dv
teacher wants. I mean, I like to show this stuff on the right because I want you to see where it's coming from and like kind of a little
Yeah.
preview of
Just
like.
get a better understanding
Mm-hmm.
of it, kind of.
Yeah, because otherwise you're just memorizing a process and like, who cares? Like what?
No thanks.
Yeah, I can memorize where the fucking mitochondria is, dude. I don't want to.
Yeah. No. Don't want to do that either.
Where's the Golgi
We haven't
apparatus?
gotten to cellular energetics yet. So.
Oh really, dude? That used to fuck me
Yeah.
up so much, dude. They're like, where are the thylakoids? I was like, dude, fuck.
What the fuck is even that, bro?
Yeah, I know. Well, that's the plant cells. The plant cells have thylakoids. I remember that one. Yeah. But then, bro,
okay.
memorizing like, okay, which one's mitosis 2, which one's meiosis like 42069 or something. I'm just like, I don't know.
Oh yeah, there's meiosis 1 and meiosis 2.
Yeah, there's so
those are-
much, dude.
Yeah, there was like you got to remember how many chromosomes are in which cycle. I'm like, okay.
Yeah,
we went over that.
Yeah, is it diploid? Is it haploid? I'm just like, I
Yeah,
don't
is
know,
it diploid?
dude.
Is it haploid at this point? Or
Dude, I'm
whatever.
like, I'm non-binary ploid or something. Like, you're like,
non-binary ploid. What?
I'm unemployed.
What the hell?
Oh,
All
okay.
right.
That's for how tall the building is. Okay, so now they want to know S of T, right? Okay, so this is where,
Yeah.
again, from this thing here, right? ds dt is equal to v. That tells me that ds is equal to v dt. All I did is I just moved the dt over.
Okay. Yep.
So then integrate both sides again, and we get S is equal to the integral of v dt. But we have an expression for v, right? What was our? This was our expression for v, right? It was way down here.
Yeah.
Good. So I'm gonna say the is equal to the integral of negative 32t minus 44, right? Yeah. dt. Technically, you're supposed to do this. So that's going to become. So what's the integral of negative 32t?
The integral of negative 32t.
Mm-hmm.
Is it what is it? Negative 16t squared.
Good. Yeah, negative 16t squared. Yeah. Okay, good. Yeah, so that's negative 16t squared because yeah, we raised the power divided by the new one. And then what about this one? What about the minus 44?
44x.
Minus 44t. Yeah, I know you want to say x, but like
yeah,
that's where
x, yeah.
yeah. You always got to check like what the fuck variable they're using here. Okay, and then you're missing
Yeah.
one last thing. One last thing.
Hold on. I'm trying to write all this shit down.
Well, you're good. You're good. You're good. Take your time. Take your time. You're fine, dude.
Alright, and then dt s equals negative 16t squared minus 44x. What was the last part you said we needed?
Yeah. So we're missing one more thing here. So I've done this.
Is
I've
it
done
minus
this.
44 that are constant?
The minus 44t. But then anytime you do an integral and you don't have something here, right? It's indefinite.
Plus. What
Plus.
is it?
Yeah. What is it? Plus c. Plus c. Plus C.
Oh, if when we take the integral of something. Yeah.
Yeah. Whenever you
Okay.
take the integral and you don't have
You do
bounds up
plus
here,
C, yeah.
you have to do plus
Mhm.
C. Is what you have to do. Exactly. Yeah.
You gotta have a constant.
Gotta have a constant. Yeah. Okay. So I want to find out how tall the building is. I guess, right?
Yeah.
Um.
Oh, I just went into a completely different thing. All right.
Oh.
Cool.
Okay.
All right, we're good. We're good.
Okay. So I need to figure out what C is, right? Because this tells me the height of the thing, right?
Mm-hmm.
At a certain time, and I know it starts. You know, at time equals 0, the thing starts at the top of the building. So if I know where the thing is at time equals 0, I know how tall the building is.
Yep.
I just need to figure out C. So how can I figure out C?
Plugging. Hold on. So we have our initial velocity.
Mhm.
Okay, wait. So I'm gonna highlight that. Okay, we
So
have our initial velocity. So how tall is the building? Okay, so would S be pretty much S of T? Would that be our height of the building, pretty much?
S of
Would
T.
C be our?
Well, no. So S of T is the position of the thing, right? Is the position of
Okay.
the ball. The height of the building. One sec. The height of the building is eventually going to be equal to what we say is like S of 0. Okay.
Okay.
Because once I find out where the ball is at time equals 0, then I know how tall the building
height.
is. Yes, because the
Okay,
ball
so
starts at the
we
top of the building.
Okay, so we would just plug in 0 for T.
Well, we would, but do you see how if I plug in 0 for here, correct, right? What do I get for
We
S?
don't have C though.
We don't have C, right? So we got to do something that we did.
C.
We got to do some. Yeah, exactly. We got to do a trick that we did last time, right? Which was, what did we do when we were trying to find C down here? We were trying to find.
Oh.
What do we
We
use?
could do S of 2.
Exactly.
to-
Yeah. You use one of
'cause
your.
That's
your-
what we have.
Yeah. Exactly. That's what you want to do. Yeah.
Okay, 2 squared minus 44 plus C.
Yes. So let's figure out what S of 2 is, right? So S of 2, I know is equal to 10.
Yeah, you know it's equal to 10. I'm trying to get my calculator right now to.
Oh,
do
okay.
all this.
You don't have to do this. No, it's not that bad, right? What's this? Negative
You got it?
16. T-
Oh yeah,
what is
wait.
it-
So
what-
2. What is that? 64.
2 squared. Good. Yeah, that's negative 64. Good. And then it's minus.
64
88.
minus 88
Good.
plus
yeah.
C. And then
Yeah.
take it all to the other side.
Mm-hmm.
That one.
So
Yeah,
minus
that one we use a
64.
calculator for.
It's 152,
Plus
right? It's
C.
152. It's 152.
I got 162
Is it?
on my calculator. Yeah.
Yeah.
Add 64, add 88 to 10.
Oh, to 10. Oh, dude. I forgot about the 10. Yes.
You forgot about the 10,
Dude, I fucked up, dude. Always forget about the
No
tens,
good.
dude. I forget about the tens.
So, our building's 162 feet then?
Yes, exactly. Yes. 152 is equal to C. Yes, right? Or 162, sorry. Which, right, when you plug in T equals 0, you figure out that's where the ball is at time equals 0, and the ball is at the top of the building, so the building must be 162.
Yeah.
Yeah. Cool. And yeah, you did
Hell
it.
Yeah.
Congrats.
It's a lot easier when you're actually paying attention.
I know, right? Yeah, it's
No,
well,
I was dozing off in class. I'm gonna be completely honest.
no, it's okay, dude. It happens all, dude. Yeah, and especially with y'all's generation has just been like bombarded by distractions constantly. That's like all you've known, like growing up, is distractions.
Very, very true.
I get it, dude. Like, it's
Yeah.
I worry about the next generation, which like literally will not even know
Oh,
what not
Lord.
having social media is. They're just be like, wait, they have these funny
I
things
mean,
of like,
yeah.
no, go on, you're good, go on.
I like didn't grow up with like a phone till I was in like what, middle school, so like
There
I
you go.
still understood like
Yes.
going outside and stuff. But
Yeah, you still understood some amount of normality, but some of these kids are given like an iPad at like age 2.
yeah, seriously. Like all my cousins like that live here at least, they all got iPads when they started school. I'm like,
Uh-huh.
I didn't get a Chromebook until I was in middle school. Like,
Bro, I didn't have a cell phone until I was in high school. Like, I didn't have shit.
yeah, that's crazy for y'all. I had my, I mean, I got my phone in middle school. Actually.
Yeah. At that point,
Yeah,
it's just
middle
it's like a
school,
safety
yeah.
thing too, because you're like, oh, I can just always reach my kids now. You know, it's just like text mom or dad.
True.
Yeah, be like, where the fuck are you? I used to just sit outside school, being like, I hope dad comes to pick me up because I can't reach him.
Yeah, exactly. Yeah.
Oh. Good. All right. Cool. I'm glad this makes more sense. Yeah. If you ever got other ones where you're like, you know, dozing off and didn't get it, just like, yeah, throw them in. Let me help you out.
Yeah, I got you. Yeah, just like I don't know why, but like the notes are much harder than like what our homework is. It doesn't really make sense.
Yeah, usually because like the notes that they give you are what we call like a generalization. As in like they're trying to teach you the theory behind it, and they use all like letters and variables, and because they're saying, oh, for
that,
every
yeah.
case, like this is what happens. But if you see an example, you're like, oh wait, this is how they actually do it. You know.
Yeah.
I'm the same way, man. Like if I read textbooks and I see all like the fancy math jargon for like explaining how to do something, like doesn't make any sense to me. But if I see an example of how to do it, I'm like, oh cool, I can see the pattern. I'm like, okay, I get it.
Okay.
Yeah. So yeah, best way to learn is
Yeah.
do questions. Do questions. See if you got them right. If you're getting them right, then you're learning. That's how I learned at least.
Yeah. So like with integrals as well, we're also a part of my like we have a website for like our homework. It's called
Sure.
Delta Math.
Delta
And-
math. Oh, that sounds fun.
Yeah,
Not.
for sure. Not.
Delta.
I mean, at least they show us examples, but like sometimes the examples just like explain it in such a more complicated way than it has to. And like at the end of class, I was like on my last problem, and it was like I did all the other problems before that right, but then this one was just like extra complicated for no reason. I was like, I don't know, but I don't have that question now.
Do you
I have
remember
this
what?
one?
Do you remember? Oh yeah.
Huh?
Yeah. Do you have another one? Yeah. Just yeah. Send it. Let me just see it.
Yeah. I feel like this one's gonna be easy though. I don't know.
It's okay. I can make them harder.
Okay.
I can
That-
make anything harder.
Yeah, for sure. Hit it my way.
Alright, yeah. Let's see.
Alright. So much quicker on a computer. Wow, that is very skinny, but you got it.
Okay, cool. Let me see. Coming in. Coming in. Where is it? Let's see. You posted it in the screenshots channel? I don't see it yet.
I
Yeah.
should have helped
Yeah.
screenshots.
Yeah, help screenshots.
Yeah. Oh, I didn't.
There you
enter.
go.
Alright,
You gotta hit
whatever.
send. You gotta hit send, dude. Yeah. Okay, cool. Got you, man. Okay, cool. Okay, yeah, this looks like general rules of like integrals and stuff. Okay, let f of x be a continuous function that, okay, minus 2 to 8 to 2 is that, and 1 to minus 8 is that. What is the value of 1 to 2?
Yeah, so I just write it out, and then like the way that he showed us how to do it is to just kind of draw a number line, right?
Yeah.
Where we write out all those limits, whatever. So I would, for example, go to like 8 to 1, negative 8 to 1, 1 to 2, and then like label their like length, I guess. or
Yeah,
their
yeah.
Number, how long
So-
they are.
So if I went from, just looking at this one, right? So this is minus 8 to positive 2, right?
Yep.
And I know that whole thing right there, right? That's equal to 8, right?
Yep.
Cool. Okay. And then I know, well, let me put the numbers of the lengths on the top. Okay. And then I know from 1 to minus 8. So this is weird. You see how you're going from a big number to a small number?
Yeah.
You want to
can
flip this
'em.
one. Good. You want to flip this from
'cause then it
negative 8.
changes the sign, yeah.
Perfect. Exactly. And this is equal to 3. That's what I really want. Right?
Yeah.
So,
Yeah, so I was doing that too. I feel like this is an easy question, but we'll see.
that's okay. Let's see if you get it. It's okay. So yeah, this ends up being 3, right? And then they want the value of
Of 1 to
3. Well, and then there's a key thing here. They put a 3 in there, right?
2. Yeah. So you would, whatever your value is for 1
Mhm.
to 2, you multiply by 3.
Exactly. Yeah. Right. And so you can see, right? If
Mhm.
if this if this is 8, this is 3. What's 1 to 2?
It's 5.
5. Good. So what's the final answer then?
15.
Nice.
Yeah.
That one's easy.
That one was pretty light work.
Okay.
Hold
I'm
on.
trying to think what would be a harder one they would give you. Because I mean, this is semi difficult how they did this with the
Ooh,
changing the
okay.
bounds and stuff.
I got another one.
Okay.
I
let's see.
think this one's better.
Let's make it harder.
Yeah, a little. I think a little more complicated. All right. Uh, Help screenshots. Bang, bang. All right.
There we go.
There we go.
Okay. Ah, okay. Yeah, making it a little bit harder for sure. Okay, cool. Yeah, dude, why are they always like flipping this one, dude? Like these. Oh, actually, this one's okay. Actually,
They're just trying to get you to think, I guess.
yeah, they are getting. Yeah, it's not too bad. Actually, I see how this is working. This is okay. Actually, sorry, it's minus to whatever. That's fine. Okay.
Hmm.
So 1 to 6,
And then -8. Yeah.
and then
Six to
negative
negative
8
7.
is This was what is this? -8. So this one is.
So the whole thing is 4.
The whole thing is 4. Yeah, so that's kind of weird. So they.
Yeah.
Okay, so the first thing is like we got to break up this integral. So this is actually going to end up
Yeah.
being 2 integrals. So this is the integral.
So split 'em. Okay.
Yeah, good. This is negative. Oh, fuck, I can't draw 8s today. -8 to 1 of f of x plus -8
Integral 8
to 1 of what?
Of 2.
Of just 2. Exactly.
Okay.
Okay.
Gotcha.
So this one you can kind of see, right? So -8 to 1 is going to be whatever this area is, right?
Yeah.
What's that going to be?
-3.
Yeah, right. Because the whole thing is 4, but this top part is 7. So, right, that has to be -3. Cool. So this is -3. And then what do you do with this?
Mhm. Well, multiply it by 2. No.
Yeah, you're close.
Because the integral of 2
Yeah, is what?
is, well, -8.
Don't worry about the bounds. Don't worry about the bounds yet. What's the integral of 2?
Well, 2x.
2x. Yeah. Yeah. So this is just 2x. And then you do this. Have you done this before?
I've seen the notation, but I don't think we've done that
Okay.
necessarily.
So whenever you have a definite integral, which means that you have an integral with things down here and whatnot,
Bound. Yeah.
bounds, yeah, you do the integral, and then you write the bounds like this. And what you do is you
Okay.
plug in this number for x, so that's like 2 times 1, and then you
Yeah, I see
subtract
that.
it from plugging this number in for x. So that becomes 2 times -8. This is
Okay.
technically called the fundamental theorem of calculus,
Mhm.
which I think they write in like fancy terms. They say like f prime of x from a to b is equal to f
like,
of a minus
some-
f of b, or is f of b minus f of a?
I think it's, yeah, that one.
Yeah. Well, this is basically because because again, what an integral is technically called an
It's-
antiderivative, right?
Yeah.
So when you take the integral of a derivative, you just get what the regular function was,
Mhm.
which in this case would be f of something. And then what they're saying is if you have bounds, it's f of whatever happens after you do the integral, you plug in b for it, and then you subtract plugging in a for it.
Gotcha.
So this right here ends up becoming, what is this? This is 2 plus 16 just equals to 18.
Mhm.
The other way to think
So
about
it'd
this... Yeah.
Mm.
Go on. You're good.
So it'd just be 18 minus 3, so
Yes,
it'd be
good.
15.
This one would just be 15, yeah.
Okay.
The other way to think about this is if you have the integral of just 2, is just think of it in terms of a graph, right? This is
Yeah.
what's the graph of 2? Of y equals 2.
It's just a horizontal line.
It's a horizontal line, right, yeah, where this height is 2, right? And we're going
Okay.
from -8 to 1. So do you see how this just like builds out a rectangle?
An area.
Exactly. Yeah.
So that's what one of my classmates was trying to explain to me, but I was also like half there. So I was like, okay, so what would the area of it be? And
Yeah.
he's like, oh, this. I'm like, oh,
Yes.
okay. And it
Yeah.
was right. So I was
Yeah,
like, all right, I'm done.
It's just a rectangle. It's a rectangle that has
yeah.
a width of 9 and a height of 2, which is why you get the
Mhm.
18. That's where that this pops out.
Yeah, I got you.
Yeah. That's it.
Hello.
Simple. What's up, Ethan? Good to see you, dude.
Are we gonna do my question next?
Yes, we'll do your question soon. Yeah, give me a second. Yeah, you're good, Ethan. I'll get to you.
All right, I'm all good here.
All right, cool. Awesome, Patty, dude. Yeah, anytime you got questions with calculus stuff, throw it in here, dude. I'm happy to help you out, man.
All right, thank you.
All right.
Appreciate it.
Enjoy your Monday, dude. Peace out.
Yeah, you too. Peace out.
Well, yeah,
Awesome. What's
that's
up, Ethan? What's up?
all.
I gotta do Teacup's question first because he asked first. But yes, what's up, Ethan? You want to talk about something? What's up?
You remember that message I just sent you today?
You said something about a graph you had to do. Yes.
Yeah. Like from November 19th or something.
Okay, from a while back. Yeah. How'd you do on it? How'd you do, man?
Okay. How did I do? How did I do? You were asking?
Yeah, yeah. You said you had to turn it in or something, right? How'd you do?
Yeah. I hope you don't believe. I hope you do believe me, but
I will believe
got
you.
a 10 out of 10.
10 out of 10, dude. Yeah, nice. That's dope, dude. Good job, Ethan. 10 out of 10, man,
Is
dude.
that,
That's 100%, dude. That's sick.
Yeah, but the thing is that the teacher said that he thinks I might be the only one who got a 10 out of 10 for that.
Well, that's great. Then you're the smartest kid in your class, Ethan. That's awesome.
For physics, yeah. I hope
Yeah.
so.
Well, yeah, we're all, I was pretty smart in my like physics classes and computer classes, but in my English classes, like I didn't do too well. So, I wasn't the best there. Can't be the best at everything.
True, but English, I really wish you could be the best at it.
Yeah, English would be cool. It's good to be able to write things. I agree with that, man. I really do.
But yeah, I am super proud of it.
I'm proud of you too, man. That's sweet, dude. That's dope.
That's
dope. Nice. And you're coming to the United States, right? Oh, I gotta mail your controller to your aunt. Let me do that. Let me do that this week. I'll do it this week. Make sure it's there when you get there. Cool. Yeah, you're coming to the U.S. in like a week or something. Did you look at those chess things I showed you?
Yeah, but my dad said that we're going to the U.S. on Christmas Day.
Oh, you're coming on the 25th. Oh, that's
Yeah, so
it's a lot further.
that's when. Yeah, and there's no way I can participate in any of those tournaments.
Yeah, well, they also don't have Christmas Day tournaments usually. People take Christmas off.
Yeah, I know.
That's all good. It's all good, dude. Did anybody talk to you about when you won the Belizean online chess tournament? Did they talk about any like real chess tournaments happening? Did they do any of that?
No.
No?
No.
Man, we gotta find you someone in Belize who like plays chess at a higher level so that you can piggyback on that. That's what we need to do. We need to find that for you.
There's no way you can do that.
Yeah, it would be the best. We gotta do it for you. Maybe I just need to come to Belize and just figure it out. Let me see. What do I want to do with Teacup? I'm trying to think what I want to teach Teacup with. Yes, this is cool. Where's like?
All right. I'll just wait for now.
Yeah. Don't worry. Let me get to you. I'll get to yours. I think I gotta do this. I gotta do Jamarcus too. Wherever Jamarcus is, but if Jamarcus is here, I'll help him out. Yes. Okay. Cool. Ooh, let's do some Extrema. I like these. Teacup, what's up? You here? Is your internet back? Teacup.
Oh, hi, hello.
Hello. Teacup's internet is back. We like that. Okay, cool. Here, we're gonna do Extrema. That's what we're gonna do. We're gonna learn about some Extrema. How was Thanksgiving? What was your favorite meal? What was your favorite thing of Thanksgiving, dog? Steak?
I
You-
ate turkey.
Ooh, turkey. Turkey's good.
No, I had steak today.
I had like ghetto steak. I had like a burger. It's kind of steaky.
Oh, I had
Is
like a fillet.
Oh wow. I need to like, yeah. What? You're eating like fillets and shit, dog? Like what? I need to mail myself to your house and be like, hello, I would like
I
a
had,
fillet for lunch.
Fillet and roasted potatoes.
Ooh, that's yummy, dude. Nice. Your mom cooks all this? Like she cooks steaks for you? That's dope. Oh, okay. Cool. Okay, cool. Let's do little bit of calculus. All right. We're gonna do finding critical points and stuff. Do you know what a critical point is, Teacup? Teacup.
Hello.
Do you know what a?
Hi,
Do you,
hello.
all right, he's back. Do you know what like a critical point is for a function?
Can't say I do.
It's okay. Critical point is where the derivative is equal to 0 or the derivative is undefined. That's what we're going to learn here. Okay. So critical point is where f prime of x is equal to 0 or like 1 over 0, 0 over 0, or I don't know, infinity, like just some other fucked up shit, you know, but usually just equal to 0. Okay? So
Okay.
they give us this function here, and they say, find the critical point of the function. And then they want you to compute what that point is. So how do you think you would do this?
So you need to find the critical point and compute.
Okay,
So we
yeah.
know f of x. So critical point where f of x is equal to 0. So we need to find when f of x, which is x squared minus 4x plus 1, is equal to 0.
We got to find when the derivative of that is equal to 0. That's what we say.
Oh, yeah, it's f prime of x.
F prime of x. Good. Yes. That's the key thing. So how do we find f prime of
Can we
x?
solve it first and then we do the derivative? Or do we
No,
do
no,
the
no.
derivative, then
We
solve?
want to do derivative first and then solve it. Yeah. Just because the function is 0 just because the function is 0 doesn't mean the derivative equals 0 there. Yeah. You want to do the derivative first.
Magic.
What's the derivative?
Let's see. So we have x squared. It's going to be 2x
Good.
minus 4x, and that's 4x to the 1, which would be 4x to the 0.
Mm-hmm.
So that would just be negative 4, I think,
Good. Minus 4. Yeah.
and plus 1.
Well, what's the derivative of 1?
I don't know, 0.
0. Yes. Nice. Okay, cool. All right, good. And then what do we find out next?
We need to find that. Oh, I think this book. We need to find. So we got a derivative. Now we just need to find when it's equal to 0.
Good.
1 over 0, 6 0, or infinity.
Just, well, this is like 0 over 0. But yeah, just do it when it equals to 0. Make life simple.
It's the same thing.
So we do-
2x
Mm-hmm.
0 is equal to 2x minus 4.
Very good.
Then we just do like plus 4.
Mm-hmm.
So now we have 4 is equal to 2x.
Good.
Do we want to divide?
Yeah.
By 2.
Mm-hmm.
That's just going to be x equal to 2. But that's not right.
Yeah, that's okay. X equals 2. This is the x coordinate that causes the derivative to equal 0, right? See if I put in 2 here, I get 4 minus 4. Hey, what's up, Falcon? Sorry for lurking for so long. You can lurk as long as you want, dude. Yeah.
I have
that's-
an essay due in like a week.
Okay. But you got plenty of time. Okay. So that's the critical point, C. We would say C is equal to 2, right?
Okay,
And then what does it mean when they ask compute f of C? What does that mean?
graph it. Find the answer.
No, find the answer. Yeah, what does f of C mean?
F of C.
Falcon.
How
Yeah,
is
everything's good,
FC?
Falcon. Awesome.
How does FC?
F of C means what is f of C, dude? Like, okay, so if f of x, right, is equal to x squared
F of
minus 4x
x.
plus 1, what's f of C?
Well, we got no C's.
Well, we do know what C is, right? We know. Oh, no. Remember, whatever you plug into here, dog, like just shows up everywhere there was an x. Okay.
Oh, okay. So that would just be what is that? It would be C squared. No, it would be no. Let's do this math. So we got 2 squared
Good.
minus 4 times 2 plus 1.
Cool. Yes. 2 squared minus 8 plus 1. Good. Okay, so that's 4 minus 8, negative 4 plus 1, so that's negative 3, right? So we say f of 2 is equal to negative 3, right? Good. Okay. Next thing they say is, okay, compute the value of f of x at the endpoints of the interval, okay?
That means it doesn't go on anymore. It means segment.
Good. So what does it mean to compute f of x at the endpoints?
Um, so we need to find when f of x is at the endpoint.
Yes. So endpoints is when x is equal to 0 and when x is equal to 4.
That's a small graph, but okay.
It's okay. So I'm going to figure out what f of 0 is, right? And then I'm going to figure out what f of 4.
0. We got 0 squared minus 4 times 0 plus 1.
So it's just 1. Good. And then what about f of 4? What's that?
4 squared minus.
Mm-hmm.
Wait, that's negative 16.
16 minus 16. Yeah. It's just
Plus
0.
one.
It's also
it's
just
all
1.
1.
All 1. Cool. All right. So this is what we know, okay? We know that f of 0 is 1, f of 4 is 1, and we also know that f of 2 is equal to negative 3. Okay?
We're grinding. So what would the local minimum be? Negative 3 and the maximum
Good.
be 1.
This would be what's called like a local min, right? It's also the absolute min, technically, on this interval,
Yeah, because doesn't go
because
lower.
nothing else is less it, right? Yeah. And so,
The absolute and local the
Yeah.
absolute and local high would be 1.
well, we don't know that. We don't know if this is a max. Actually, let me think about that. Yes, I think you're right. You are right, actually. Because if this is so like if you were to draw the graph, right?
My
0,
math is
2, 4. Down here it's like here, right? And then up here it's here and it's here. This is like
Is my
1.
mathing?
Your math is mathing, yeah. So you're right. So we know this is the lowest value, so this must be this must be the highest value, yeah. So
Well,
the
we
key
could just say it's the local maximum instead.
I would
We don't wanna
just
say it's the absolute.
yeah, let's just say it's a local max. Local max. I don't know. Anyways. Yeah. Cool. And yeah, so that's what the min and max are, right? The min in this
Now,
case,
what is the
the max is 1. What's up?
extreme value?
Yeah, extreme values. I think that's also the min and the max. What the hell is the extreme values? Wait, what? Excuse me? What's extreme values?
It's your textbook.
Your textbook, he says. Yeah, what's an extreme value, dude? What?
It's when 1 plus 1 is equal
Oh.
to ish.
Oh, no, it's just find the critical points. Cool.
Kind of cheating.
Yeah.
Don't you already know
Oh,
that?
oh, it's the same thing. Oh, they're just asking us
Then
to
why they
find...
gotta use fancy names?
I mean, yeah, why they use a different word, dude? I don't know. Okay. Yeah, on 0 to 1, it's different, right? Because 0 to 1, there is no critical point, right? Because the critical point was at 2.
So we're just computing it.
So you're just computing what, like, f of 0 and f of 1 are, which is dumb.
Oh, no.
So
No, f is 0.
we know f is 0, right? And then just f of 1 is just 1 minus 4. It's just negative 2. Yeah.
That was easy.
Yeah, that's easy. Yeah, cool. Good
I
job, dude.
actually did one on myself this time.
Yeah. I mean,
Oh,
next time,
what
I'll ask you
question?
something harder next time, but yes. But that was good info.
Very quick question.
Very quick
Determines
question.
fate of the universe. On Wednesday, can I harass you by sending you my essay so you can review it again?
Yeah, didn't I do that last time for you? I helped you out with your essay?
Yeah, I got a 98.
Oh, hell yeah, dude. Yeah, send me your essay. I'm happy to go over it, you know, help you out.
Dude, this time it's not even compare essay, it's just a fiction essay.
Oh, okay. That sounds
Oh,
fun.
it's fiction, but it's fiction based on a real event.
Okay, okay.
It's a satire story.
A sad life story? I see.
No, it's satire. You're
Oh,
making
a
fun of me.
satire. Oh, okay. I thought it was like a sad life story. I'm like, bro, that's I
Yeah, it's
don't wanna-
about a sad person. His name
That's
was Batman.
no. Okay. All right.
His
Yeah,
name
yeah.
was Doc, but he spends all his rent money on random children.
Yeah, I do technically. Just don't say that too loud.
The IRS would be, that's not tax paid off.
Bro, the IRS actually did call me today. They were asking. Yeah, dude, I shit you not. They did actually call me today. Well, it was a California IRS basically. Yeah, they were questioning
Also,
like.
it's the CRS.
Yeah, it was the California Franchise Tax Board. They were questioning one of my seller permits, and I'm like, they're like, you got this in 2018, and I was like, yeah, I don't do that anymore. It's what you said. I used to sell T-shirts and stuff, so I thought it was
Now
funny.
you just sell life.
Yeah, I do. Anyways, I thought
Sell
it was,
life, right?
I thought it was funny. Yeah, yeah. I'm like I sell my time and services. Like I don't sell physical goods
Oh.
anymore.
How much you cost it for? It's like what, $200 for private tutoring.
Yeah, 120 these days, if it's in person. 90 if it's
Alright,
online.
have a good one.
You too. CT Cup. Let's see. Is Jamarcus here? Let me ping Jamarcus. If Jamarcus is not here, then I will do Ethan's. Let's see if Jamarcus is here, real quick, because he did ask. And you here or playing with friends? Falcon, how's stats going, dude? How's the stats class? You got a final coming up, yeah? Starting to put it all together. If you get a practice final, Falcon, for your stats class, like, let me help you with it. You know, I was helping someone with stats last week. Okay, we'll see if Jamarcus shows up. Otherwise, Ethan, let's do yours. I like yours. Yours is cool. 2 masses on a string. It's going okay. Well, let's make it go great, dude. Why is it not great? Let's make it great. Okay. What's up, Ethan? Ethan? I'll tag Ethan. Ethan maybe sleep sings. 2 blocks of masses M1 and M2 are connected to each other. What's up, Ethan?
Hello.
Yeah. Ooh, this is a good question. This is called rotational motion, Ethan. Okay. Okay. So they're saying we have these masses here, right? And they're rotating around at a frequency F. And they want an algebraic expression for the tension of each segment in the cord. Oh, wow. Oh, that's kind of cool. Okay. I got to teach you about centripetal acceleration is what I got to teach you about for this one. Okay? Let me do an easier example first, and then we can do the harder one maybe next time or something. Okay. Okay. So, have you done force diagrams on things before?
Which kind of force diagrams?
Well, here, let's say I have a 5 kilogram block being pushed with a force of 10 newtons. What is its acceleration? Okay. You ever thought about that?
No.
Okay. So we have a block. Okay. 5 kilograms. And then what you have to do is you gotta draw forces on it. Okay.
Alright.
So, do you know the forces that are acting on this block? Have you gone over this yet? It's okay if you haven't. I'll teach it to you.
The forces of the block?
Forces on the block. Yeah. There are things that are like
Yeah,
pushing on this block.
Yeah, like for example, you, like the person pushing it.
Good. There's a person. Yeah, there's me, right? So let's say the force of me, right? And this is equal to what? How many
Mhm.
newtons?
10.
10. Good. Okay. There are some other forces acting on it.
Gravity.
Good. That points straight down. Do you know what that force is equal to?
Yeah, you don't even need to ask that. It's 9.81.
Good. Times the mass, technically. It's mg.
Also, you don't have to run that out to 10, you know.
I'm not going to round it up to 10. Not going to do that. So you see how this is the mass times 9.81?
Yeah.
Now there's one other force that we're missing.
The normal force?
Good. Normal force, yeah. Normal force points this way, right? Do you know why they call it normal? Do you know why they call it the normal force?
No.
It's not because it's like not weird or something. It's
I don't think it would be something like that.
yeah, okay. Do you know what it means for something to be normal to a surface?
No.
Have you heard the
They're trying
word?
to balance it with the
We are going to balance it with gravity. Do you know what it means for something to be perpendicular to a surface?
like the same place, like it's gonna cross sections or something.
It means it's gonna have a 90-degree angle, is what it is. That's what being perpendicular is, right? It means straight up from a surface, okay?
All right.
Something being perpendicular is also the same thing as calling it normal. If something is normal to a surface, it's the same thing, okay? So the reason why we call it the normal force is it points 90 degrees to whatever surface it's on. This is why the same thing happens when we end up doing like inclined planes. This right here ends up being the normal force because you see how that's 90 degrees to the surface it's on?
I see that.
Good. Okay. Awesome. Okay. Now, what we know, right, Ethan, is that if this block, right, is not falling through the ground, what does that mean about the normal force compared to the force of gravity?
They're both 9.81.
They're both the same 9.81 times 5. So we say this is equal to the force of gravity, which is equal to the 5 times 9.81. Okay?
Okay.
Okay. Now, so this block, right, is being pushed to the right with a force of 10 newtons, which means it's going to accelerate. Do you know an equation that tells you how much it's going to accelerate based on the force that's being acted on it?
No.
Okay. Here's the equation we're going to learn. It's the sum of the forces is equal to the mass times the acceleration.
All right.
Okay. So what we want to do is we want to add all the forces in a certain direction to get the acceleration in that direction. Okay.
Okay.
So let's look at this, for example, okay? What is the sum of the forces in the x direction? What's up,
That's
initial?
10.
It's just 10. Good. Yes, that's equal to 10. And that's equal to, right, the mass, which we know is 5, times the acceleration. Okay?
Yeah, which is 9.81.
No. That was acceleration due to gravity. That's going up and down. We can solve for A here, right? What's A?
Yeah. I think I know what you do.
Okay.
I think you try to get it alone, so you like divide 5 on both sides, right?
Good. Divide by 5. Divide by 5. What does that get me?
2. 2 is
2.
equal to A.
2 is equal to A. Do you know the units for A? For acceleration?
M/S.
M/s squared. Meters per second
You
squared.
know, you know that graph I was talking about?
You could also do this if you really want to, but this is kind of weird.
Oh, no. There's like index notation where we do like M and S -1.
Yeah, so we could say
No,
ms negative 2.
I'm sorry.
Yeah, that's correct too. It just looks weird. I don't really like it. No.
But you know,
Weirdo.
you remember that graph I talked about?
Yes.
We had the roles switch there. Like we had the units switch. The letters switch.
Yeah.
You wanna take a guess?
Which ones? Which ones do we have switched?
Like M/S squared. What do you think is gonna be reverse of that?
M/s squared. I think it's gonna be m squared s, as if you were messing up. Yeah.
No, I mean it's actually reverse.
Oh, I don't know. What is
Like
it?
both S squared / M.
S squared / m. Oh no, that's not right. Yeah, it's not
I
S
mean-
squared / m.
I mean that's what we did for our graph. That's what we did for our graph.
Oh, did we? Like when I did it with you? I did it wrong?
No, just with what my class did for a lot of experiment.
Yeah. Okay, that's cool. Well, you know, get it right next time. Initial. Oh, okay. Initial says he's at. Yeah, I want to see what he's getting at Steak and Shake. I'm hungry. Nice. Does this make sense to you, Ethan?
Yeah.
Good. Nice. Okay. Awesome. Next time we'll do the harder one. But I want to make sure you understand the basics. I want to make sure you understand like how to do forces and accelerations first. Okay. This is good stuff.
Okay.
How's your math going, by the way? How are your math classes and stuff?
Nothing new so far.
Okay. The second you get something new, you tell me. Okay.
All right.
So I can help you out. Initial says he's at Steak and Shake. I want to see what he can get at Steak and Shake for me. Can you pick me up some Steak and Shake, Initial, dude? What do they have? I think we have a steak. I don't think we have a Steak and Shake in California, not in Los Angeles. Those milkshakes do look good. Voted number one voted milkshake. That's cool. What's up, Initial? Yeah, come up the stage, dude. Are you gonna get a salad, dude? What about us? Like chicken fingers? Chicken fingers look good, dude.
Man, imagine Smash Burger if it was ass.
Smash Burger. Oh, I
you've
know
ever
Smash Burger. The Smash Burger has the really fat fries, right? Or that's Fat Burger. Sorry.
Yeah, that's Fat Burger. Smash Burger has the really thin, greasy burgers.
Oh, okay. Thin, greasy burgers.
Imagine In-N-Out but ass. How about that? I can
Dude,
definitely
In-N-Out is
support
fucking great. I fucking love In-N-Out.
In-N-Out is fucking amazing, but imagine that, but budget as fuck.
Bro, this Frisco Melt looks pretty good, dude. You gonna get the Frisco Melt?
I am not.
Oh, okay.
I gotta choose drive-through or go
Dude,
inside.
this looks like what I just ate today. I don't know if people are
You know what?
earlier
Fuck
on this.
it. I will order food on the drive-through.
Okay, good. Do it. Yeah, it's
Pure entertainment.
it's the American way. I saw a funny like stand-up thing about the drive-through. You know how like you get to the first counter and they make you pay, and then the second counter they give you your food. It's kind of like it's like a drug deal. They're like, well, you got to give us the money first, and then we give you your stuff. And they talk about how like the intelligence of the two people is different. Like if you're working the front and you're in charge of the money, they make sure you're like really sharp. But if you're just giving the food, they're just like, oh, just who cares? You know, like just no loss. So apparently the strategy is at the second counter to go to them and be like, hey, could I add a whatever? And then they're gonna be like, I don't know. And they'll just give it to you.
Yeah.
I don't know. All right, let me see if Jamarcus is here. Let me do Jamarcus's last class.
We
Jamarcus.
finish our.
What's up?
That's my question.
We did finish your question. Yeah, that was your question. We did your question. We did this one, Ethan. Yeah.
Hold on, I'm connecting to my car speakers instead.
Okay. What's up,
I
Ethan?
also did the I also did a CSF test today.
You did a what? A computer science thing?
Yeah, a computer science fundamentals test today.
Oh, good. Okay, man. That's good.
Do I know how that went?
Yeah, how'd it go?
Yeah, it went pretty easy. The last part, do you know what's a Fibonacci sequence?
I know the Fibonacci sequence. Yeah, that's a pretty cool thing.
We basically had to write a program with that.
Oh dear, that would be kind of tough.
No, that was easy for me.
Oh,
That's
just
like
because
20
you're just
lines or
adding.
something.
Yeah, just adding. Well, I'm glad you're getting it with. That's with a bunch of loops, right? Loops.
No, we
Oops.
don't use loops. We just do calculations. Like,
Oh, okay.
but yes, I'm pretty sure I got 4 points for that part.
Hell yeah, dude. Good man.
I feel like
Yeah,
I'm kind
go
of
on.
improving.
That's good, dude. That's really good. I'm trying to see how we do this one. Okay, Jamarcus, this one's tricky. Let me see. Is this one any worse? Maybe. Okay. I think the strategy for this one is to try to combine these things to have common denominators. So, I think this is gonna be.
Yeah, I've already been here once today.
You already been what? What?
I've already
Initial?
been to this place once today. I came here after school.
What? No, dude. You can't eat fast food twice in a single day, dog.
I have to tonight because I didn't get to cook before I left.
Oh my god. Are you going to work or something?
I
What?
got a robotics meeting, bro.
Oh, robotics is sick. I like robotics.
Well, I do nothing except test out the robots and then play Guitar Hero.
Okay. But, I mean,
live the
that
fucking life.
sounds like you're doing something. It sounds like you're well qualified for a position in management.
Well, my position is marketing, but we haven't started the competitions yet, so.
Is it for first
point in
robotics?
going-
Are you doing first robotics?
There is no stage robotics here.
Oh, well, what's it called then?
It's just fucking robotics.
Oh, okay. All right. There's no
We don't have
competition for it?
stages, It's just everybody's in the same thing.
Oh, okay. Well, that's cool.
All right.
I like
I'm
robotics.
going up to
Robotics
the
is
window
great.
meeting.
Okay. What's up, Josue? Jose? 509. Okay. So let me see. They want to get C times that plus A times that plus B. Huh. Do I, like, want to foil this? I don't know if I want to foil all this, man. I really don't know if I want to. Oh, God. A plus B plus C is equal to 5. What is the trick? What is the trick? What's up, Jose? I really don't want to foil this. I don't. But maybe I have to. And then, like, pull it out as partial fractions again? Ew. Try to see if there's an easier way to do this one. Yo, what's up, Phil? Philippe. I was just helping Patty earlier. Okay. I'm just gonna ask Wolfram to do like some. I know I want to go to Steak and Shake now. You guys got me hungry. What's this? 1 over A plus B. I just don't want to foil this by hand. It's just gonna suck. And that's plus 1 over, what was it, B plus C. And then it's plus 1 over, what was the other one? C plus A.
Man, they spilled my fries in the fucking bag.
Dude, that's the best, bro. Gets all like the extra, dude. It gets all the extra salt dirt, dude, at the bottom, dude. What are you talking about?
Hey, guess what?
All the extra dirt at the bottom, dude. That's what you want.
No, I don't.
If
Because Steak and Shake has really tiny fries.
Ew. What? Say no to tiny
So
fries,
it's
dude.
like now I have to go sorting around for fucking fries.
Yeah. Dude,
They're
the,
bullying me.
the American struggle, dude. I tell you. Okay, here we go.
American dream is not
Dude,
a dream.
it's not a dream,
fries
dude.
This tiny.
Okay, wait. This turns into this. Oh, I see something. I think I see something. Well, maybe I do. Maybe I don't see shit, actually. But, okay. Okay, so what? This is like A squared plus B squared plus C squared plus 3. And then it's AB plus AC plus BC. All over this huge... Gonna dip out. Yeah, good to see you, Nisha. Over this, like, mess. Absolute mess. We don't want to deal with. Oh, best line of fit? Yeah, let me help you with best line of fit. I know how that shit works. I love best... Dude, linear regression? Hell yeah. I'm about that stuff.
You know, I did some best fit line thing.
Did you?
Yeah, in grass.
Did you do R squared values and stuff? That's all the cool stuff, man. CAB.
No R square values. I don't know those.
Oh, R squared's cool. R squared is really cool. That's how you tell like whether a thing is fits it well or not. I want to see if this comes out to Jamarcus. I'm sure there's like some fun tricky algebra here. Oh my god! Oh, that's so gross. No. Oh my god! What? Why? Right? C plus A plus B. Hmm. So I want to like combine this. No. Okay. This is what we're trying to get to, right? I know that this whole thing is equal to 9. So let's see what the difference is between this thing and this thing. It may be, honestly. Maybe if I multiply by this whole thing by A plus B plus C. I think it does actually. Watch it. Watch this. Watch this. This is actually kind of cool. Let me take this thing. So here, I think I can. Can I not click on this? Okay, whatever. We'll just multiply the two together. Watch this. We're gonna say times A plus B plus C. And let's not make it a capital C. Yuck. Yeah, dude, it's so ugly. Well, this is what they do in Russia, apparently. They just, like, hate you. I think this is going to come out to be the same thing. Uh-huh. Where's the expansion? I want the expansion. Yes. I want to end it all, dude. Yeah, seriously, dude. What the hell, man? What the hell, dog? I just wanted to see if this was like something cool. Okay. Do these things look at all the same? No. Yuck. Yeah, it's so tedious. You're right, Jose. Yeah. Yeah, I don't know. Well, I mean, shouldn't be that. There's some trick here. Because they're saying that, right? They're saying A plus B plus C is equal to 5. And then they're saying 1 over A plus B plus 1 over B plus C plus 1 over C plus A is equal to 9. And now they're asking, what is C plus A plus B, right? What happens when I... Like, this is equal to this, right? Which, yeah, my first thought was to try to combine this into a single thing. And that's where we got this. Right? This is the same thing. Right? And then this is also equal to this. So I was trying to see if there was a way, maybe if like this multiplied by this, I would get this, you know? Because then I could just do this times this is this, but it's not. It seems like it almost would be, though. Yeah, it's very yucky. Yuck, yuck, yuck. Did Penn Center try this one and he said it took him hours or something? And he still couldn't get it? Let me see. A plus B, C plus A, B plus fuck off. Holy shit, these be wilding, dude. Dude, I love this dude. Yeah, this is great. Yes, I can't wait. Holy crap, I just wasted 1 hour of my life trying to solve them. Yeah, see, he already spent an hour. Yeah, he's a pretty good math guy. Yeah, what is the trick? What's the trick? Did they give you a hint? Jamarcus, we get any sort of hint? I'll take a hint. Take any sort of hint here at this point. These are always like, I call these like, this is like my like going to the gym type questions, you know, because again, are you actually ever going to need to do these in math? No. No. But it's cool to see the tricks. The tricks are cool. I mean, this is another very interesting one, right? They give me they give me all these three expressions, and then they want the value of this. So they want ABC over AB plus BC plus CA. So I feel like this is again some like fancy partial fractions type thing. So let me just see. I'm just curious. So what's that? That's ABC over, what was it? ABC over AB plus BC plus CA. Let's just see what Wolfram tells us. I'm just curious. Uh-huh. Bro, that doesn't really help me out. Series expansion? Nope, 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 nope. Nope, don't need to do that. Well, that doesn't really help me. Let me think. Let me think. Maybe let's try like messing with this. Cause wait. Oh, maybe I see something here. Okay. Do you see how AB is equal to A plus B over 17 from the statement right here? So AB is equal to A plus B over 17. BC is equal to B plus C over 19. And then CA is equal to C plus A over 18. Okay, because I see these things. That's just like my intuition there. I kind of see that. So I think this is ABC over, and then it's A plus B over 17 plus B plus C over 19 plus C plus A over 18. Okay. I could combine those into nice things. And then let's see this. 1 second. A is equal to A plus B over 17B. B is equal to B plus C over 19B. C is equal to C plus A over 18A. I'm gonna be honest. I'm going to be completely honest here. Just give up. Yeah, dude. But I kind of want it, dude. It's kind of cool. Wait. Cause then do you see how I can put? Sorry, this is 19C. 1 sec. A times B times C. Okay, hold on. A times B times C is then A plus B times B plus C times C plus A, right? All over 17 times 18 times 19, and then it's ABC. Okay. I feel like that's right? Okay. Oh, it's close. It's so close. Well, okay, I have an expression for ABC now, right? I know ABC squared, right, is equal to all that. Yeah, no. But I have an expression now. I have an expression for this, which is this. I just need this to maybe pop out somehow. I want it to. I want it to. I really do. Okay, let's see if this actually let me see if this comes out to be some nice like common denominator shit. Maybe we'll find it. Okay, so this is a plus b over 17. Just doing this because I don't want to have to like I don't want to screw up like a dumb integer mistake. B plus c over 19. C plus a plus a c plus a over 18. All right, let's see what we got. Look at this alternative forward, dude. What is this? No. What? Dude, look at all these garbage ass fucking numbers, dude. Damn. Damn, girl, who hurt you? Who hurt you? Who hurt these Russian people, dude? Who hurt them? Yeah, because I know this isn't going to turn into anything nice either, right? Yeah, I know. I was trying to see what the reciprocal was, yeah. So, one second. A plus B. B plus C. C plus A. Let's see what that is. It's okay. Yeah, can I just get... I just want an expansion, please. Thank you. It's really ugly. Yeah, super ugly. Man, it doesn't really help me either, does it? Look at all these expanded forms. It's not really helping. Okay, I don't know, Jamarcus. Plug in the value of A and it'll work out. Maybe look at the reciprocal. It'll all work out. I don't know if it will. The value of A that Wolfram gave. Which one? This? Oh Jesus! Yeah, you want me to plug this thing in? You want me to plug this in? Jesus Christ! Oh my God, no. That's assuming this is equal to 0. It's beautiful. Yeah, no. Okay, cool. Jamar, I'll still give you a point just because like I appreciate the challenge. If anybody else like actually knows how to do that question, I would love to. Actually, Jamarcus, when they tell you like please come like show me how they do that one. I want to know. Yeah, I think it'd be cool. Okay, awesome, cool. Thank you everyone for coming to office hours. Had a fun time learning with you guys. Doing hard as fuck math is always interesting. Yeah, it's great. W stream, thank you. ASMS8. What is it? AMS Monkey? Yeah, cool. Awesome. Wait, is this Taco Cat? Is it you, Taco Cat? Anyways, yes. Also, thank you to our subscribers. Appreciate you, Sam, Sensation, Pen Center, Taco Cat, and our Discord server boosters. You guys are awesome. Moog, E, Noise, Obama, Teacup, Al Prince, Jamarcus. Yeah, all great. They won't go over them, dude. Cool to check this out. Yeah, thanks, man, dude. Yeah, Jose, what's your story, dude? Are you a student or something? How'd you find us? That's always like to figure out. Did you find us from, or you just joined, actually, today? Where'd you find us from? I know I've been posting a lot. I found you through your Instagram reel. Cool. Yes. So cool. I'm glad you did. Like Instagram has been like blowing up recently on my You know, it's weird. Like certain videos will hit, certain videos won't. Like this one, I think did decent. What was it? What was the last one I just posted? Yeah, this one got 9K, and I think the one before 165K. That was a lot. Jamarcus asks, when is the winter's thing? I'll figure it out. We may not start until next year, honestly. I don't know. It's getting kind of close to the end of the year, and I like to give enough time for everyone. And the animation was really helpful. Awesome. I appreciate that. Yeah, those are my Ukrainian animators. They're great. But now I gotta find more money for them because they're like, we need more money to make more of these videos. And I was like, oh, okay. I might have to animate some of the stuff myself. But yeah, I've been doing some recent ones in chemistry because people ask me for chemistry videos. But yeah, Jose, if you ever have questions about any like physics questions you have in class, math, whatever, any of your classes, dude, like I'm basically a free tutor here online, and I'm happy to help you out with it because it helps out other people who are watching. So that's what we do here. So I don't know if you saw there's a whole channel called like Help Screenshots right here, and this is where all the students post like all their homework questions, and I just go through them on the stream. So it's kind of my like giving back to the community stuff. It's cool. Let's see. Yeah, I got to still figure it out, guys. Yeah, I got to figure out like buying you guys prizes. Honestly, that's what I got to do. I got to figure out money. All right, good to see you, Jamarcus. Yes. Okay, cool. All right. Our next stream, if you guys ever want to know when our next stream is, you can always type in exclamation. Well, here. There's our stream on the Twitch. I'm currently a college student. Definitely going to come over for some more office hours. Yeah, please do. Here's our schedule, by the way, Jose. That's all the different times we stream. So Monday, Wednesday, Friday, I do these sometimes in this case 2-hour long streams where I'll just help you out with whatever classes you have. And then Thursday is kind of like an AMA. You can just ask whatever you want. Some people ask about, I don't know, fitness, relationships, or why is the sun red or something. I don't know, whatever they want to know. I help them out with it as well. So it's a cool community. We got a lot of fun people in the Discord. A lot of characters. Yeah. Okay, awesome. Here, let me move this down. Okay. The other thing we do, I don't know if you play video games at all, but so really how like most of the students found this this Discord was through Fortnite or something that I was playing with them. So I keep up with that tradition. So I still play Fortnite with all the students. And I do that on a different stream called Actual Gaming, which we'll raid over here in a second. It's super easy. So if you're in the Twitch and you're just hanging around, keep chilling. It'll pull you over into Actual Gaming. If you're in the Discord and you want to like hop on the VC or like play with us or even just like say hi, we're gonna do that in like the recess chat, which there's a voice chat down below that does it. Apparently there's a new Fortnite. There's always a new Fortnite. I think it's like this whole they're like updating it like every week or something, right? It's like a new season or something. Anyways, yeah. So they're cool. That'll take them over.
Yeah, like this is just for now. Maybe they're trying to come up with a new idea.
What is it now? What's the new season, Ethan?
See, apparently we're like in season X or something, which was like
Season
season
X.
10.
Season X. Oh, that sounds cool. Let me see if I've even updated my game.
Either I am wrong or it's season 9.
Okay.